Okay, let's go begin. Let's begin. This is trigonometry homework 7.3, 13, and 29, which shows the questions at the end of yesterday. So let's jam. Number 13. Let me just kind of go back real quickly here to what we did. And so real quickly redo the problem itself here. So I got B, got little c, I have angle A. So when you put it all together here, I'm just going to draw a generic triangle, scalene-ish. I'm just going to put ABC. You could put yours anywhere, however you want it here. So if A, B, and C are defined as vertices of a triangle, that means little b is going to be defined opposite that. Little c is going to be opposite that. And then we go from there. So angle A is 4320. And notice it sets up this little side angle side. You have an angle that's included between the two sides, and that sets us up for the law of cosines. Now, law of cosines, remember this, there are 6 different formulas, but because we're trying to find the opposite side, that lends itself to 3 different formulas. It's either a squared is equal to something, b squared is equal to something, c squared is equal to something. In this case, we want a squared. That's the formula that we want, and it looks like the Pythagorean theorem when we started off right here. And then what we do is we subtract 2 times the BC. And then we have cosine of the angle that's opposite the side that we're trying to find. So cool, let's punch all this in. And I think we had no issues through this, and I think I know what the issue is here. So let me punch this in real quickly here. 2 times 0.923 times 0.387, running out of room here. It'll be cosine of 43 degrees, 20 minutes. And let's punch this in into a calculator, which I think most of you guys did well, and put it in here. Now, your calculator, TI-82, 83, all those calculators, very nicely, they will actually do the order of operations correctly here. Because they're going to do order operations correctly, you can just punch this in as is, and it spits out the value here. So this little squared button right here I'm going to use, plus 0.387, and then minus 2 times 0.923, and notice I am not punching in the 0 in front of the decimal. That's fine, because your calculator will do both if you want to punch that in because you need to. That's fine. All right, 43 degrees, and the way we do degrees here is we put this little angle button right here, so put second. If you click on number 1 or enter, you'll get your degree value, and then what you do is you just click enter 20, go back to this angle value, and scroll down and click enter, or you can actually just enter number 2. Close off the cosine value here, click enter, voila. Now that is going to be a squared. What we want to do is we want to take the square root of that to get us the answer. So we're going to go square root of the answer, press enter, or I usually close off the parentheses, press enter. There it is. Let's see, we're going to go 1, 2, 3, 3 decimal places after the decimal, so it's going to be 0.694. So how about that? Technically this is A now, right? So A is equal to 0.694. Okay. Okay, up until here, I think everything was great. It's after this that's the problem. And so here it is, and this would be good clarification for things. I'm going to just put an A on here. So A is equal to not A squared. Okay, now let's do this here. Let's draw this out. Kind of seeing how this is going to work, okay? But notice one thing before we draw this out. Notice this is like 0.6, 0.7, right? Notice this is like 0.4-ish or 0.3. And notice this is 0.9. Notice our little b value is huge compared to A and B. So here it is. If you have a sneaky suspicion that the angle you're trying to find is more than 90 degrees, then you should use the law of cosines to find it, okay? That's kind of where we're at on that. Oh, kilometers. I should put kilometers for the value here. So here it is. Most likely, that angle B is going to be bigger than 90 degrees because 0.9 is just huge. And so what we do is we'll just use the law of cosines again on angle B. Now this time we're going to use cosine of B. This is the angle formula for the law of cosines. So let's punch this in. So again, if you have a sneaky suspicion that the angle measurement you're trying to find is more than 90 degrees, you got to use the law of cosines to find it. Okay, this one's going to be a big one to put into a calculator. It's that whole thing. I put the extra brackets in there. And so let me go to my calculator again. Oof, okay, so extra parenthesis. For the top value. So 0.694 squared. I'm going to use a little too small squared to get to what I need out of it here, because therefore I don't need to use extra parentheses. That's what I'm kind of banking on. 23 squared. Okay, that's going to be the top value divided by everything on the bottom. So an extra parenthesis for here would be 2 times all that right there times all that right there. Okay, close off the whole entire bottom and click enter. Okay, now that I still need to take the cosine value of it. And the little negative right there actually tells you it's going to be more than 90 degrees right there. So that already gives me that. So cosine inverse of my answer. Dun, 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 dun. Oh, you know what? I better make sure I'm in degree mode. So yeah, I'm in degree mode. Okay. So click enter, voila, 114. Now, really cool little thing over here. Let's go back to angle measurement, and we're going to convert this into degrees, minutes, seconds. So boom, our answer from there, converted to degrees, minutes, seconds. Love it. Okay, that's going to be 114 degrees, 14 minutes. Perfecto. Okay, I'm going to check the back of the book to make sure it's the same. This is number 13. You know, the back of the book says 10 minutes. That's the fun little part right there. So, okay, so cosine of all that stuff there gets us, okay, why is it 10 degrees at the end? Because notice what we were given originally was this value. So the book is trying to say it's not actually the nearest minute, it's actually the nearest tens of a minute, because that little zero is technically not a significant figure. And so even though it's 14, on the calculator gave us 114 degrees, 14 minutes. We round this between 10 and 20, and that will round down to 10. So that's the answer back of the book. It's the nearest tens of a minute, not the nearest minute. Okay, we got that, and we got what we wanted right here. Boom. Now I know this triangle actually looks like this more so. So angle A, angle B, angle C. What do I know so far? Plug all that stuff in. I know this, I know this, and I know this. I know angle A is 43.20, and I also know the angle B now is 114.10 according to the back of the book. Okay, so the only thing I'm still trying to find is angle C, and let me do it two different ways. Angle C could be found by using the law of sines, and it's going to be sine of C, so sine of A over little a, and sine of C over little c. And this point, let's multiply the 0.387 across, and it's going to be that now, equal to sine of C. And then don't forget, we're going to take the sine inverse of all of this right over here. All right, one more calculator problem. Here we go. Book. So clear all that. This is going to be, let's see, on top, 0.387 times the sine value of 43. And then you can do the same thing here, 43 degrees, 20 minutes. Number 2. I'm going to click enter here. I'm going to get that. Divide by 0.694. Got that, and I'm going to take the sine inverse of that. All right, I got that, and then I'm going to, again, angle measurement here. Convert degrees, minutes, seconds, go. And I got myself 22 minutes, 29 seconds. And let me just check back of the book again. Yes, it gives me, of course, 30 minutes. So let's go with it here. So this will be angle C is 22 degrees 30 seconds. And the question comes up, Mr. Hengieff, why you do all that work? Since we have two angles, can't we find the third angle by just adding up by 180, adding the two angles up, subtracting from 180? Absolutely. I just want to verify to get the same thing. So if I did that, plus the two angles, adding up the two angles I know, so the 20 plus 10 is 30, that's going to be a 751. Adding those up, subtracting from 180. Let's see what happens here. See if I get the same thing here. So I need to borrow 1 degree from 180 degrees. So I'm going to say this is 179 degrees now with 60 minutes. And 60 minus 30 is 30. Voila. 9 minus 7 is 2. And then 7 minus 5 is 2 with a little degree. Yes, it gets me the same thing. Awesome. There it is. So there's number 13 with all the different pieces put together. All right, question comes up, Mr. Hengieff. Before I even knew about angle B, whoa, let's see if this, could I have solved for angle C already using law of sines and then did angle B? Absolutely. You could have done that easily. Sorry, like this here. If I did not solve for this first, but I know that I got this, and then I'm going to, instead of solving for the bigger angle first, I actually solve for the smallest angle using the law of sines. Absolutely. That would have given you 22 degrees, 30 minutes. And then you could have used this little piece right here. You could have used the addition and subtraction from 180 to get you angle B. That would have worked just fine as well. Okay. Hopefully you understood exactly what I was talking about there. Okay. Let's jam. This is number 29. 29 is this little bicycle. So I'm going to draw this out. Let's see. There's my, there's my, in fact, let me go to it here. That's my top tube there. This is called my seat tube coming down, and we've got the hole for my pedals. And then I have my down tube right here. That's cool. Okay. And then don't forget a little water bottle holder right over there. That's cool. All right, and let me put my seat. I'm going to draw my little seat here. There's my seat, and I walk around. There it is. I get the seat. Okay, and then we go on the back end here. The back end goes like this. Let's see. Now this one does have to connect, so I'm going to go from here to connection, and then here I'm going to go from bottom. Actually, no, I need to put this little piece right inside here because to finish off the frame, and then connect the bottom with the hook for my wheel. Okay, I gotcha. There it is. Okay, my frame is built. I have my angle measurements now. So middle of the tube as much as I can, draw it out. This is my middle of the tube going through the top middle of the tube. I might just go out of my frame, but that's okay because I'm just getting angles here. And I'm going to go from here to here. There's my pieces. It says bike frame geometry, a 47 centimeter. Okay, so I got 47 on top over here. Has a top tube length of 47.0 centimeters. It has a seat tube of 47.5 centimeters. That's cool. And then it has an angle measurement. This is my seat tube length. The seat angle is 78.0 degrees. That's cool. Okay, I'm good to go. I think I can work with that here. It says find the length of the down tube. So I'm going to redraw this again, just real quick here, just the triangle itself. Just the triangle itself. Let me redraw this here. So there it is. There's my triangle. I get to label this ABC no matter which way I want to go. So this is 47.0. This one is going to be 47.5. That's my angle measurement is 78.0 degrees. And again, notice it's this little property of SAS. The angle is an included angle between the two sides. I know I'm going to have to use the law of cosines to get out because I don't have an angle and an opposite side here. And it says find the down tube right there. Okay, I'm going to have to label this just so I can use the formula. So I'm going to label that guy, the upper left is A, upper right is B, and the lower angle is C. Okay, if I do that, what I'm really trying to find is little b according to my law of cosines formula. So b squared is equal to, okay, fill in the, kind of like a Pythagorean theorem, but you're really just adding those up. Now subtracting off of 2 of those multiplications of the sides that are on the right hand side of the equal sign and cosine of the opposite of angle of b, which is capital B. Okay, let's plug all this in. So A, according to my little diagram, is 47.5. B is just 47. Oh, sorry, C is just 47. And then it becomes minus 2 times 47.5 and 47 and cosine of the given 78 degrees. I'm going to punch this into a calculator, see what we get. Okay, and don't forget after that, just also do a square root of that as well, right? So punch that in. Let's see what we got here. So 47.5 squared plus 47 squared minus 2 times 47.5 times 47 times cosine. Do you need to put the multiplication between the two? You don't. I'm just kind of putting it in there just so I see what I'm multiplying with. Let me check my mode again. I am in degrees. That's true. Enter. Whoa, big number. 3,500. 3,563. I'm going to take the square root of that just so I can do it all in one step. And boom. Okay, 49 point, let's see. These guys are in terms of 1 point past the decimal. So 49.5. How about that? 49.5. And we are in centimeters. So B equals 49.5 centimeters. Okay, hopefully that was helpful. And we finish up.